Hey everybody, welcome to episode 10 of our podcast, Innovating the Industrial World. My name is John King. I'm the CEO of Cross Company and your host. We're here to talk about pneumatic rotary actuators, which is kind of cool. Like, what the heck is that, right? So that's about moving things using air. And I got two special guests today, which we're real excited about. Wade Wright is with Cross Company. Wade is our head of our OEM business unit for our automation group. Wade, do you want to introduce yourself?
Sure. Wade Wright with Cross Automation. I've been with the company now for 26 years in various roles in sales, application engineering, and now managing a business unit. And thus my involvement with our guest today, which is Rotomation.
I'm Norman Lane with Rotomation. I'm president, and I've been with Rotomation since 1987. I've been in the industry for 45 years.
We love using you guys for stuff because we run into environments all the time. Like you said, things getting banged around, things in incredibly corrosive environments. There's places in the industrial world that are not they're not very pleasant to things that move. So for those of folks who don't know, pneumatic rotary actuator, Norman, you might want to explain that a little bit about when and how they're used. If you think about a rotary actuator, that's like a motor, right? So an electric motor, but this way we're doing it using air. Because there's places that we go where you can't use electricity.
Right. And it's a very simple product compared to like a servo or something like that. Limited rotation. I happen to have one right here. It's a cutaway, and maybe you can see it. So you can see the inside. There's a rack.
Yeah.
There's a pinion. Whoops. There's a piston. So piston moves back and forth, which turns the shaft in a windshield wiper type of motion.
Yeah.
So that is the most basic of our products. We also make multi-position rotary actuators. So 3 positions. So it can go to some place in the center. Doesn't have to be in the center. Anywhere in between the outer positions. That's a 3-position actuator. We also make 4 and 5 position. And then we have a unique product called an indexing actuator. Should have brought one in, but it makes steps in one direction, incremental steps. So it's always going in the same direction.
Yeah.
A lot of applications in automation. It's a simple, very rugged and simple substitute for a servo system if you've got a repetitive indexing type of application.
Right. So you're going boom, moving.
Boom,
We're going to talk
boom.
about that in a minute, which is kind of
Okay.
neat, but you can do
Yes.
it in places where you can't do it with a servo or any kind of electricity.
That's right. That's
Yeah,
right.
I think when you talk about rack and pinion, just so that everybody knows, like the most basic kind of rack and that everybody can relate to is a rack and pinion steering, right? So you have a steering wheel, it rotates, and you're moving you're moving the front wheels. Well, imagine that in reverse. You're taking a pneumatic cylinder, pushing it on one side, and it rotates something, which is kind of cool. So you're taking this kind of motion into rotary.
Yes.
So let's talk a little bit about some of these really, really unusual environments or why we would use pneumatic. We talked a little bit about this before. We've got a really cool thing that we've used that was in an environment that we were filling something that was incredibly corrosive, right? You mentioned about toilet bowl cleaner. So
Yes.
let's explain that to us a little bit.
Okay, we can. We were approached by an old customer of ours. Actually, they're building a machine for a company that is wanting to fill bottles of toilet bowl cleaner. You may have seen these. It's a consumer item. It's got this funny little nozzle on the top of the bottle, so you can stick it down in and squeeze the stuff out, and it squirts up underneath the toilet bowl. So this is very corrosive material. It's sodium hypochlorite, sodium hydroxide, and some other magic ingredients that we never really understood what they were. But we were told by the customer that the only thing that's really reliable is 316 stainless or some plastics.
Yeah.
We couldn't make this thing out of plastic. It just wasn't going to be tough enough. They needed to be able to grab the bottle, rotate it 45 degrees. So now the nozzle's sticking straight up.
Okay.
They put a filler down into the hole, fill it up, rotate it back to vertical, transfer it to there's 8 of these actuators on a table. They transfer it to another table with another 8 actuators. They rotate it back again. They stick a little nozzle into the bottle that regulates the flow or something, and then they cap it, and then it comes out. So it's a continuous operation, high speed, bang,
How
bang,
fast is
bang.
this thing running?
I don't know. Pretty
But like,
fast.
it's really, really fast. Just
Yes, really, really
right.
fast. That's why
Yeah.
they have 8 of them on a table. It's like 8 feet in diameter. So it gives them enough time as it goes around to fill the bottle or to put the cap on. So we started looking around for a parallel gripper. We don't make parallel grippers. We don't make any grippers. But I look at parallel grippers that are on the market, and they all have this open mechanism on top that with cams and stuff, which would be impossible to seal in this nasty environment.
Yeah.
Um, we know how to seal a round rod. Well, everybody does. And so we said, well, we'll make our parallel gripper with round rods that can be sealed very effectively. We also make rack and pinion rotary actuators that are a natural parallel motion. So we developed, this is actually the device.
Yeah.
Here are the tooling plates, go in and out.
Yep.
So there are 2 racks and a pinion in the middle. We didn't make the fingers that grab the bottle, but the customer made their own tooling.
Right.
So this is the gripper part, and it's married to a dual rack, very compact rotary actuator, which is also all 316 stainless.
Yeah. So look how small. Yeah. It's really, really small. So it's going to fit in a nice place. Um, because you got 8 of these side by side. And again, for those folks that don't know, a parallel gripper is kind of what it sounds like. It's just jaws that go like this. But you can't find anything out in the open market because they've got all the mechanism is right there for all that sodium, whatever, to get into, and it's going to chew it all up.
That's right.
So these things can last a lot longer than anything else they might do.
Yes, we were told that Viton seals or FKM seals would hold up, and they have held up pretty well. We did have some kind of early failures and tried some Calres, super expensive, long lead time. Didn't do any better, so we just ended up beefing up the seal design instead.
Got it.
So we had to make some, let's say, kind of innovative design changes or features to this product to make it work.
Yeah, that's innovation that nobody really thinks about, right? Like you've got this really nasty stuff that you've got to fill, and you've got to come up with a better way to do that. Because if you do it with electricity or motors and that kind of jazz, it ain't gonna last more than a
No,
week.
no. So yeah, I mean, we had to, we got this rotary joint between the rotary and the gripper. We've got to seal that. And one of the issues there was when that thing's going back and forth, it generates a lot of kinetic energy, which is
Right.
hard on a rotary actuator. It tends to break things.
Yeah.
So the joint between the two has to be really robust to handle that impact. So we designed a special pinion shaft that has a big flange on it that it projects out of the rotary part and bolts onto the back of the gripper.
Mm-hmm.
Well, in order to do that, we had to reverse our normal bearing loading. Typically,
Right.
we do what we call a front to front loading. This had to be a back to back to get that geometry to work.
To figure it
And
all
then
out. That's
and then
awesome.
a big face seal that would stand up to that material also.
So it's got to be small. It's got to work in with all this sodium stuff flying everywhere, and it's got to work fast, which, like you said, a lot of kinetic energy. So it's bam, 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 bam all day
Bam,
long.
bam, bam. Yep.
Cool.
Yes.
Well, Wade was telling me about this one that we did in a bakery that was kind of cool. So you'll tell us a little bit about that.
That's probably one of the first ones that you and I worked on, Norman.
Yes.
Where we have a customer that makes bakery equipment, and they needed to get into the dough making side, and the challenge is they needed to be able to handle flour in the atmosphere. And you don't think about just regular household flour being corrosive, but it's amazingly corrosive.
Yeah, it will tear stuff up.
It will tear up seals, bearings, you name it. And so, we solved it with that indexing actuator that Norman had talked about earlier. And of course, making it correct me if I'm wrong, but it ultimately that was stainless steel as well, right? Was that stainless?
No, it wasn't. It wasn't stainless. It's pretty much our standard materials, but we added features to keep the flour out.
Right,
You know,
right.
a rack and pinion actuator, the pistons are flying back and forth, and all the air behind the piston has to get to the other side. And there's
Yeah.
a limited amount of flow path for that. It's just a long story, but just the clearance around the rack. And that was causing like a negative pressure inside the actuator, which was breathing the flour into it. Flour mixes with grease, turns into concrete. And pretty, very short
Yeah.
time, your actuator's dead in the water.
Right.
So we did several things. We added seals that we don't normally have to add, and we drilled passages parallel to the rack bore so that it would allow much easier airflow. And we put longer pistons with wear rings and carboxylated nitrile seals, because these guys are running 125 cycles a minute, 24/7. They rack up millions and millions of
125
cycles.
cycles a minute. So literally a half a second, they're going bam, bam, bam,
Bam,
bam,
bam,
bam.
bam, bam. Oh yeah,
Yeah. And I guess what you're talking about cylinders that are going back and forth, but this is all rotating the same, like it's rotating the same direction, 90 degrees. I think we talked about 90
yes,
degrees,
90
exactly
degrees.
90 degrees every half a second.
Yeah. And one of the cool things about this, to me, it was just so exciting to watch this thing. What it was doing was it taking these little dough balls and it throws them. There's a vertical conveyor with
Yeah.
trays that are going to go through a proofing oven and then into the real oven. Um, so these little dough balls would come down a ramp and land on this thing they call the log, a plastic piece with pockets in it.
Yeah.
And then as the tray would come by vertically, it would flip them 90 degrees and toss them through the air into those little pockets.
That's awesome.
Timing had to be exactly right
Every half a second.
every half a second. And they said, once in a while, that they would know what the actuator was, the seals were wearing out because they'd have dough balls all over the floor. We solved that problem, but it was just a really cool concept.
Oh, that's how they knew it was screwed up. But so then, and we were able to solve that problem. That's pretty awesome.
Yes, we extended the lifetime by about a factor of 3 or 4, and we also rebuild the things. Everything we make at Rotomation is fully rebuildable. We sell the parts. We rebuild them here if they want, and we have bakeries all over the country, all over the world,
That's pretty
who are
awesome.
using that actuator.
So flour flying everywhere, rusting everything else if it's not, if it's not made out of the right material, and then you're throwing balls in the air.
Yeah,
Good stuff.
Yeah, that's pretty awesome.
yeah,
So kind of that's where it's the powder in the atmosphere is getting into seals and that kind of jazz. Now we have another thing that we've done in the pharmaceutical industry, which is around saline solution, right? So Wade, you want to explain that one a little bit? Saline solution, it's basically seawater. We know that's going to
Exactly.
corrode the
It's
bejeebies
salt
out of
water.
something.
So you're dealing with salt water. And again, that was another one we came to Rotomation with to help us solve, because the customer could not get any longevity out of their packaging lines where they were handling the saline solution. And the awesome thing about that application too, Norman, if you remember, is we were able to match up to their previous solution. We could match up the mounting and the shaft,
right.
which allowed them to go to all their plants worldwide and put our solution in as a drop-in replacement for what they had.
Yes, yeah.
Oh yeah, that's amazing.
That
It
was
was a stepping motor, I think. So we built an actuator with a flange that dropped right in, a nickel plated metric shaft that direct substitution for the stepping motor.
correct.
And I think that I also heard that one of the advantages that they got out of this thing was that the stepping motor was, how steppers are like that. Well, our actuator is much smoother operation, generated less foam in the saline solution, so they
That's
could
right.
close up their package more quickly and thereby increase their throughput.
Yeah, and
So,
think about increasing throughput like that when you're doing it in plants all
oh
over the
yeah,
country. Like that's a big
millions of
deal.
these things. Yeah, this
That's
is
a
a
really big
very
deal
high volume product.
when you're selling that much and you increase productivity, increase the efficiency of it, or you're making more in the same amount of time. That's huge value. That makes a big difference.
Oh yeah, and of course the whole front face of this actuator was designed to be hygienic with Teflon, virgin Teflon shaft seal, and no mounting holes. Uh, so they were very happy.
Designed from the ground up to be able to fit into a place, presumably for something that wasn't working well or not lasting as long.
Correct.
Right.
Now we can just stick it right into the existing machine.
Yes.
Yeah, that's like, retrofitting with new technology. That's pretty awesome. And
Hmm.
and all of a sudden they get more throughput.
Yeah. And probably lower cost, I would bet.
I would have to
So,
believe it was low
Oh,
cost.
yeah.
Right.
yeah. Yeah.
So,
So,
Norman, tell us a little bit more about some of the other materials you guys were using. I mean, we talked a little bit about aluminum. We have stainless, and then you're making stuff out of all kinds of funky materials.
yeah. Well, our primary material for the bodies and end caps and stuff is a standard anodized aluminum, which stands up to a lot of stuff. But if the next step up is a hard coat, which a lot of people are familiar with, we use that primarily for wear resistance, but it also holds up pretty well to saline situations, ocean conditions, as long as it doesn't get scratched up too much. Another step we have taken several times in the past for food processing and certain other things is nickel plating.
Yeah.
Nickel holds up really well, and it looks great, and you can put it right onto aluminum. So your product is easier to make, and it's lighter weight, and it's more like our normal stuff. The only downside to nickel is that if it gets scratched,
Yeah.
now the whatever
The plating's
salt or
not
whatever,
there. Yeah.
yeah, then it can just go in there and eat it up. I mentioned that our standard material. This is a product. This is the only thing we make that is not a rack and pinion actuator, but
Okay.
it's a little hard to see because it's a cutaway, but it's a very small, very compact, short stroke rotary
Yeah.
actuator.
Tiny little thing.
Tiny little thing. Well, we also made that one in stainless steel,
Gotcha.
and you can see that the seal in the front is PET. So this thing is completely sealed up. It can go into nasty environments,
Yeah.
and then we also made it out of PET. And I
Got
think
it.
John's going to explain what that stuff is.
Yeah.
Right?
Well, we call that industrial plastic.
Yeah, industrial white stuff.
Yeah.
It's very, very light. It's very corrosion resistant, and the pharmaceutical
That stands
industry.
up to a lot in industrial environments.
Yes. Yeah.
I mean, a lot of things that we don't even think about, right? When you're, next time you're going into the drugstore or department store or something and you're getting your saline solution or your toilet bowl cleaner, the stuff that's inside there, if it's flying around, it's going to really tear some stuff up. And those folks got to be able to make that. So
Right.
those are things that we just kind of take for granted, don't really think about.
Yeah.
That's what we do.
Well, so when we need to go to stainless, like, I don't know, Wade, you may remember, you get some manufacturers of smokeless tobacco,
That's right.
which is corrosive, very
Oh,
corrosive.
big time.
That's
Yeah.
very
So we made some multi-motion actuators, so it would have both rotary and linear motion, and it would stick this little boat inside the vat of tobacco and then pull it out and dump it into some kind of testing device. And for those, we used 303 stainless because it's vastly easier to machine. It was the tobacco wasn't as corrosive as like we're talking about the toilet bowl cleaner. So if we can, and it's always up to the customer. If we can use 303, we'll go that way. Save everybody time and money.
Sure. That's awesome. Well, you can see that we get pretty excited about some of these things, using all these different materials, tackling these different, difficult places to do things. We kind of love this stuff. So thanks so much for tuning into our podcast, Innovating the Industrial World. If you have any questions or comments about anything you've heard, we would love to hear from you in the comment section below. We would love for you to subscribe to our podcast so that you know when the next one comes out. And we appreciate you coming. Thanks.